Like
Okay.
I got a sneeze stuck in my throat.
Well,
All
my
right.
intro is fairly long, so don't worry, Christine. We'll be good. Okay. Greetings, Earth and Space Explorers. Welcome to Doc Waller's Earth and Space Report for Friday, July 31st, 2026. I'm your host, Bill Waller, an astronomer, science educator, and communicator, coming to you on a beautiful summer's evening in my hometown of Rockport, Massachusetts. These Earth and Space reports are intended to engage and inform people like you who are curious about Earth as a planet, who care about our life sustaining biosphere, and who wonder about the greater cosmos and all that it has engendered throughout space and time. Video recordings of these reports are archived on the Earth and Space Reports YouTube channel. They are also in regular rotation on Cape Ann's community access cable television channel hosted by 1623 Studios. I'm grateful for the continuing support shown by local science educators and their students, Cape Ann cultural colleagues, cohorts of the Gloucester Area Astronomy Club, myriad Earth and space scientists, educators, and communicators, far flung friends, family, and other curious folk. Thank you for your active participation and encouragements. This evening, I'm delighted to be hosting Dr. Christine Hirst Bernhardt, chair of the National Astronomy Education Coordination Team representing the United States for the International Astronomical Union. I'm a part of this team of volunteers, and so I'm especially glad to have Christine joining us this evening. In addition to her international activities, Christine is the incoming president of the National Earth Science Teachers Association, as well as STEM Education Coordinator at Northern Virginia Community College. Recently, she has been working with the National Academies of Science and Engineering to assess the state of Earth and space science education in our schools nationwide. The results of their survey will inform the future of this often overlooked academic discipline. In her presentation this evening, Under the Same Sky, Omens, Orbits, and Optical Illusions, Christine will explore how people throughout the ages have interpreted the heavens as a source of meaning. Planetary alignments signaled upheaval. Eclipses marked divine action, while the zodiac mapped human identity onto the stars. Entire cosmologies and creation narratives emerged from these recurring celestial patterns. Such evolving interpretations reveal a deeper cognitive impulse for humans to search for pattern, agency, and structure. Over time, the sky has not changed, but our tools have. Under the same sky that once carried omens, we now predict orbits and diagnose physical processes. That shift reflects not a loss of meaning, but a refinement of our understanding. So, let's get going. The Zoom platform is all yours, Christine.
All right. Thank you for that amazing introduction. That was awesome. All right. I am going to share my screen. Come
Alan Winter, excellent.
on. First.
There you go.
All right. And hopefully this is all going to share seamlessly.
I just see your.
There
There
we
you
go.
go.
Okay. And we don't need closed captioning, hopefully. All right.
Yep,
See
looks
my
good.
screen, right?
Looks good.
Great. All right. I am now not able to see you, but I will try and monitor the chat. So again, thank you so much for that introduction. I've always been really fascinated by the connection between space and faith and our search for meaning. And this is really my attempt to try and tie those things together. So, before I do, just a tiny little bit about me. Some of the parts of my story really define who I am and what I bring to this, and I think it's important to touch on. My first love was space, and my first memory was of the Challenger disaster. But I was really told that if I didn't want to be an astronaut, that studying space really wasn't a thing. So I pivoted towards my other love, which was music. And my life has always been filled with music. My mom is an amazing musician, so I pursued that forever. Actually entered college as a music major. And over the years, I was just really told that I wasn't a science person, and I came to believe that. When I was in my tweens, my mom came out as gay. And in high school, we moved across the state. And in a new school, I was tormented. I was bullied. We didn't have any protected classifications, even in the state of California. So we experienced some pretty significant discrimination and violence. My grades went from A's to F's. I was really angry. I was hurting, and no one noticed. I was really told that I was not college bound. I was funneled into low level courses. I changed schools, and I attended the first charter school in the country. It's actually designed for students both like me and also that needed an alternative setting. And also, since it was Southern California, there were actors there. So I graduated with many celebrities. We actually had People Magazine at our graduation. Entered college as a music major and Native American Studies, my other passion. And I really put off science until my last semester. And that was when I took geology, and it rocked my world. All of the puns went
Mm.
into outdoor education and adventure education to really combine my two loves because I really saw geology as a way to explain the world around me. And I knew that if I had learned science that way in high school or as a younger person, I would think differently about my own academic trajectory. So, really, for 2 years, I taught science outside through games and experiential learning, and I realized that I really loved the relationships and experiences that I had with kiddos, and I wanted to have more than a week with them. So became a classroom teacher, and I became the teacher that I really needed. I taught high school earth science. That happened to be the lowest priority course for students that no one prioritized. It was like teaching myself, so I saw it as an opportunity. They were right where I was. So I brought in all the games and fun from outdoor learning. I made it a transferable lab elective course, and I created these legendary labs that I still hear about 20 years later, and was asked to teach astronomy. So, of course, I said yes, but I didn't know enough, so I had to go back and get another master's degree. And when I learned about cosmic dust and the formation of the solar system, one of my students asked if we could capture it on a high altitude balloon. And I said, I don't know, let's try. And just being open to that really just opened so many doors. My students showed me what science education really could and should be when we position them as knowers and doers. And through that, it opened up these amazing opportunities. I got to go to Chile as an education ambassador. I got to fly on the Sophia mission, but I really credit that all to just being open to students and their questions. So I really became full circle and became a teacher in space, just like Krista, and have had the opportunity to serve my country on Capitol Hill as an Einstein Fellow. And what I really love about astronomy is it ties back to these fundamental questions. And this was what I would always pose to my students is where do we come from? Where are we going? Are we alone? Because these are the questions that really underlie all cultures, all societies, is this search for meaning. And I feel like astronomy really seeks to answer those same questions. So when I would have students in my class and they would say, well, why does it matter? These are the questions that humans want to know. And I think that they really underlie all of our explanations and also our early explanations about celestial phenomena. So that is where I am starting this from. In teaching the lowest level learners, they always wanted to know the why. They had to know that why. So these are the things that I always came back to. So for a lot of you, some of these things I'm going to talk about are going to be extremely basic, and for you, I apologize. But hopefully, maybe you'll learn a thing or two. So first off, why do we search for meaning? In order to really understand why we look for meaning, we need to take a look at cognitive science. My PhD is in teaching and learning, so this is something that is near and dear to my heart. In this book, in Frankl's book, Man's Search for Meaning, he describes this fundamental need to find it. Even in the most random events, that need is so strong that he describes it as our primary motivation to live. So much so that survival in the most awful settings of concentration camps, which is what he studied, could be predicted by those who saw some even teeny tiny meaning in their experience. So he looked at people who had lost all hope, become apathetic, which I probably would in a concentration camp,
Mm.
and that those were the people that often succumbed to diseases such as typhus. Whereas people that were able to attach some meaning, even in the most brutal of situations in concentration camps, those were people that didn't get sick as much. It's obviously many other factors, but he did find correlation to people's attachment to meaning and hope. So our search for meaning, his thesis of this was that that is imperative to living. So I'm breaking up this talk into a few different parts, and the first part is how we read meaning in the sky. Oh wait. Oh, sorry. So across cultures, the sky has carried meaning. We have been able to look across celestial phenomena. We've been able to try and predict other phenomena, and we've been able to find sources of our identity. We see things like calendric systems, origin stories, harvest migration, time of year, reverence for planets, and even fear of events. And also, one of my favorite things is that the earliest astronomers were also the priests. So they tied a lot of this to ideas of heaven and of God and of these heavenly places. And this is every culture was really tying a lot of these big overarching themes to the sky. So there is a group that I'm a big fan of called the Native Sky Watchers. They release a lot, they do webinars often, and they do a lot of talks and public outreach, sharing their two-eyed seeing view of astronomy and the world. And one of the things that they share is this idea of the sweat lodge. And the Sweat Lodge legend is one that originated on North America. And it's a pretty complex myth. It has four distinct star formations, including Corona Borealis, that becomes the Sweat Lodge. It has a giant
Hmm.
that is Orion. And that giant traded in spirits and could capture spirits and transfer them from one spirit being to another. And this amused the giant, and it caused this mass confusion and fear. We can see in Aboriginal Australian astronomy, the Western constellations connect stars. Aboriginal astronomy connects the dark dust lanes, which is pretty interesting. So, same sky, different pattern recognition. Ancient Indian astronomy is
Hmm.
also really fascinating because it really illustrates this connection between astronomy, mathematics, calendric systems, and spirituality. Like many ancient cultures, Indian cultures looked to the sky for practical and spiritual reasons. They carefully tracked the motions of the sun, moon, and planets. They created calendars. These determined the timing of festivals and supported their agriculture. And one of the unique features was the nakshatras, or the lunar mansions. And I have a picture of that there. And these are 27 sections of the sky that trace the moon's monthly journey. And if you think about it, if you know the difference between a lunar month and a sidereal month, 27, like that is precisely accurate, 27.5, the exact time for the moon to get back in the same place in the sky. So, but by the 5th century, the mathematician and astronomer Aryabhata proposed that the Earth rotates on an axis. So this was, long before other astronomers were talking about this, and he developed methods for predicting eclipses. That represents a really important transition from interpreting celestial events to explaining them through observation. Then, toward the end of the 5th century, the Babylonian astronomers divided that ecliptic that we see across the sky into our 12 equal sections of 30 degrees each. This is really analogous to their calendar's 12 months of 30 days. So, in doing so, they developed the first known astronomical coordinate system. This assigned each section of a constellation located in the sky along the ecliptic at that time of year. All right, have your phones out. This is an interactive presentation because I taught high school, so I am all about keeping your attention. All right, please scan the code.
Eh,
Is it working? Oops. Okay, we'll go back.
Wait, hold on. Thanks. The unmuted thing popped up. Okay, there we go.
You should be able to scan with the phone. I checked it beforehand. Yep, perfect. I'll give you guys another 10 seconds or so. Hopefully, you know what your sign is. All right, I'll give you 5 seconds. All right, keep that phone out. Come on. There we go. Okay, so I'm sorry I could not delete the previous um, responses, which is really annoying, but you're going to add to it. So you are either going to open this QR code or go to slido.com and put in this number and tell me how accurate you would say your horoscope is. Are you able to access that?
We have to scan it again, the QR code.
Yes, this is a different QR code.
My sign is
Sorry, keeping you on your toes. There we go. Now we're seeing some changes. Middle of the road. I'll have a couple more of these that are on this page specifically, so you can just keep that out.
I haven't gotten in yet.
Okay.
What's going on? Okay.
Go.
Slido.
Nice. Got a few of you in there. No one said one.
Yeah, a question. What do you mean by accurate?
Judgment call. Do you think it was accurate for you?
In terms of psychological description, or in terms of where the sun is in the sky, or
Like the one that you just did from that previous question, the one that I gave you, like based on what your sign was, that horoscope. That's what I mean.
did you look at it? No, I didn't. Why not?
So from this, that's what this is. Okay. So I do have a lot of slides to get through. So looks like you guys are like middle of the road. All right. Spoiler alert. You all got the exact same one and I made it up. My students used to love and hate that. So turns out everyone wants to find some meaning to that. That is our human nature. I have done this for 20 years where I will intentionally mix them up. And I always end up having people that will just be vehemently sure that theirs is correct. And actually, what I did was I spliced that together from a bunch of them. So it's accurate for no one. Sorry. But we want to find meaning to things. That's our human nature. We always that's what makes us uniquely human. And we've done this for a long time. So astrology has some pretty ancient roots. During the Renaissance, this was considered the queen of the sciences. It was actually believed that birth, growth, decline, everything in the material world, in the divine realm was really linked to this. So there was this guy, this astronomer named John Dee. He was an English mathematician. He was an advisor to Queen Elizabeth, and he actually really helped shape early navigation, a lot of policy. He pursued alchemy. He thought that he could communicate with angels. But he was a very learned man of his age. And he really leaned on these tenets of astrology. And he came up with this hierarchical structure of the Renaissance universe that was really accepted at the time, the divine realm and a celestial realm and an earthly realm. And astrology really fit into this structure because he said that planets and the zodiac really acted as these intermediaries between the divine and the material worlds.
Mm-hmm.
And astrologers will note that the planets at birth are what maps a person's psychological, emotional, behavioral blueprint. That's the basic tenet, in case you didn't know. And that indicates one's core personality. So one's strengths, life challenges are based on that position in a specific zodiac sign and houses based on the key planets. So the sun, the moon, Mercury, Venus, Mars. And they represent personal drives, while the outer planets influence generational, long-term, transformative life themes. And astrology really became this means to interpreting the sky. And there are 70 million people that read this every day. Or a quarter of them believe that the celestial position influences daily life. 34% believe that it is very or sort of scientific. And I recently looked this up. And one of my favorite things that I used to give to students is I made up this assignment about whether your astrological sign could be used as a factor for your car insurance. So some insurance companies and statistical hobbyists, they periodically look for correlations between things like astrological signs and accident rates. And they found that certain zodiac signs supposedly have higher crash rates. So there was actually an article that was published This was in 2011. This was by Allstate, and it said that Virgos have the most crashes. And if you look at that chart, wow, they actually do have a lot of crashes. But this is where scientific literacy is really important because they had to release an apology 4 days later. They said that this was really intended for entertainment purposes, but this created quite an uproar. So if you really look at this, Allstate then had to respond to these misrepresentations. But even these big data sets can produce these spurious correlations when people are continuously looking for meaning. And we're going to come back to why this ends up like this. And if you know, then you know. But we know that these have absolutely no role in how we base, how one drives or anything. But there is an actual reason why Virgos would statistically have more. So I'm not saying these numbers are wrong, but the cause is wrong. So one of the other ways that astrology has been used is in trading. There are stock market traders who have attempted to use planetary positions to predict the stock market. There was a very famous one named W.D. Gann, and his idea, he created this chart. This shows financial astrology in practice. So there's a price chart on the bottom layer. That jagged line is the actual stock market price over time. There are planetary symbols in there representing the sun, moon, Jupiter, Mars. There are vertical marks in there when dates of certain planetary alignments occur. There are markers, conjunctions, oppositions, and supposedly the markets follow cycles that are tied to angles, transitions, and phases. Even today, there are financial astrologers that are advising investors. And this may surprise you or surprise people because some hedge funds reportedly examined this and they experimented with some of this because we look for pattern recognition. And sometimes acts of randomness can create this belief that that there must be something there, and if we look hard enough, we'll find it. There has even been astrologically influenced politics. So at the highest levels of government, celestial interpretation has really influenced some key decisions. After the assassination attempt of Ronald Reagan in 1981, the First Lady, Nancy Reagan, she consulted an astrologer named Joan Quigley to help determine the safest timing for his travel. And that practice remained a secret until 1988. And it really became quite a controversy. And astrology actually determined his travel schedules, the timing of speeches, public appearances. Once this became public, this caused a lot of controversy. PBS actually ran a documentary on it. I tried as hard as I could to find a clip of it and put it in. It exists somewhere, but I'd probably have to go to a library and get like an actual film copy of it. I could not find it on the interweb, but there are links to it. It exists somewhere. But in when PBS made this documentary, they noted that the astrologer's advice actually affected the timing of his schedule, not policy decisions though. So if you look, you can see Nancy Reagan's name in the upper right there, and you can see like the actual astrological calendar there, and you can see his travel marks indicated on that page. So the sky watchers of thousands of years ago must have deduced that if the movements of the planets had any significance, it must be to inform those of us or those of them who could read those signs, and they might be able to interpret what fates were held in store. So even to this day, some people really believe that the changing positions of the sun, moon, and planets can have a direct effect on our destinies. So there was this planetary, oh, is it going to play? Good. We know that in 2025, I got to speak to a high school about this, which was pretty neat right before this, the planetary parade. And this was probably more what it looked like. Planetary alignments are another phenomena which many people attach meaning to. There was a great conjunction of 1584, or 24, sorry. So in the early 1500s, astrologers predicted this catastrophic flood because Jupiter and Saturn would align in the sign of Pisces, which was a water sign. So they said, oh, there's going to be a flood. This prediction came largely from an astrologer, and it claimed that this planetary alignment was going to trigger massive rain. Europe would be submerged by this global flood. People began building boats. There was this mass panic across parts of Europe. The nobles began preparing escape plans. I can just picture like the Tawn in Bridgerton, like planning an escape. And when the predicted date arrived in February, it was dry. They were wrong. But even in 2000, I remember this, I'm dating myself, planetary alignment still sparked fears of this catastrophe. So I used to live right by Griffith Observatory. And this was like a mock thing that they put out. And like I lived very close to this, and my, yep, people of my age were very believing that something was going to happen. So in 2000, the sun and six of the planets, they said that they were going to line up like cosmic billiard balls, and the alignment had a bunch of doomsdayers predicting it was going to be the end of the world. Obviously, it wasn't. So these are some news clips that I found. Planet alignment in 2023 means what it could mean for your star sign. Planets aligning is the end of the world near. That was from 2000. Astrologers predict alignment chaos. Planetary alignment didn't end the world in 1919, but one professor thought it would. So lots of news. CNN even said had to issue something saying that there was not actually a doomsday in store because people were just panicking. Um, so the second part of my talk is moving this from pattern seeking to moving to mechanism. So we are looking for consistently as humans this meaning, but we really had this shift in science where we're able to attach a mechanism to that meaning. So we know that ancient observers were actually observing real patterns. This wasn't imagined. Astrology was trying to interpret those patterns in terms of human meaning and trying to attach meaning to what they saw. But astronomy was asking these different questions, asking what physical process produces these patterns, not just what does the pattern mean. So astrology was then seen as the science that connected the heaven and the earth, explaining the harmony of the cosmos. But as science began shifting towards the physical laws and mechanical causation, astronomy replaced this symbolic interpretation with these testable mechanisms. So Carl Sagan pointed out that astrology makes claims that sound scientific, but they don't actually have a mechanism. And the zodiac chart interprets these patterns symbolically, while astronomy explains the same objects through functions like gravity, orbital motion, and physics. This is a picture I used to always show my students of the celestial sphere. And if you teach astronomy, if you've taught intro to astronomy, you've probably done this as well. Thinking about it like a bowl over our heads containing all the stars and galaxies, all the things we see. And that is often easier to conceptualize. I thought I had a landline for a second. That is often easier to conceptualize how the ancients understood these events. So we know how fast light travels to our eyes, and then we can determine how far things are. But what we're seeing is really just a projection effect. Even if we take a look at Orion, the belt stars in Orion, the farthest one is 1,500 light years away, but to our eyes, they appear to be at the same level because of the projection effect. But they have wildly varying distances. And our physical location on Earth affects the way we view the night sky. So, how high something appears in the sky, the portion of sky we see it in, also the sea of background stars. So, if we're looking at or where we are, determines where we see something against the sea of background stars. And where we are on the planet determines what we see. I used to have my students try and learn navigation from Southern California, so not exactly, maritime, but understanding that the altitude of the pole star is equal to the latitude of your observer, and that's how we know what latitude is, and that's all dependent on where you are on the planet. So we know that ancients use this for navigation. And you are now getting a quiz because you get to do that same thing. So take a look at these and see if you can notice the pattern. You are looking east, there is a pattern. Looking north, looking south, because I'm going to show you a picture and quiz you. All right, have your Slido phones ready. All right, which direction are you looking?
Could be so.
Haven't seen that move, but hopefully you selected north. That's our pole star, and we can see the circumpolar zone rotating around it. That was an easy one. This one's harder. Ooh, where is my picture?
Hmm.
I am so sorry. I'm going to skip that. That one would have looked like this. So we know things rise in the east, set in the west, and they transit in the south. So that's the trick to knowing which they are. Sorry about that. There are going to be a couple more.
Hmm.
So if we were to actually look at, and this goes back to the slide I showed you about the zodiac signs and car crashes. So an actual scientifically accurate zodiac does not treat every sign as just 30 days. So if we take a look at this, how long the sun spends in every sign is not the same because each constellation, remember, this is a projection effect of stars that appear to us to be close together in the sky. And we can see that Scorpius is only 6 days long. And we can see that Virgo is 45 days long. So now if we go back to look at that, Virgo has more because the sun is in that sign longer. So there's just physically more Virgos. So if we were to have an actual scientifically accurate zodiac, this would be what it would look like. But none of you said that you were the sign of Fuchsius. There are actually 13 zodiacal signs, not 12. If you were to look along the ecliptic, you would find Ophiuchus. That is the serpent bearer, but that was largely forgotten. It was probably intentionally left off because it didn't fit into the Babylonian system of 12 months, and the Astrological Society in the 1800s voted to leave that out. But that is our 13th sign. So if you are born between December 1st and the 18th, you're not a Sagittarius, I'm sorry to tell you. You are an Ophiuchus. But not every zodiac sign corresponds to a month because the sun spends a different amount of time in each of them. So the sun is passing through these boundaries of the zodiac signs for differing lengths of time while it's traveling along the ecliptic. So it's only passing through Scorpius's boundaries for about 6 to 7 days and much longer through Virgo. And obviously, those signs change over time. Earth's axis performs this wobbling motion at about 26,000 year intervals. So we call that precession. And it's not massive. Mars wobbles much more, but that does shift the constellations of where we see them in the sky. So while Aries was visible on the ecliptic starting on March 1st, according to Babylonian time, today that's Pisces. We also had a different North Star. So now our North Star is Polaris, but in Babylonian times, it was actually the star Vega. So we actually had a very different, not very, but it was a shifted celestial sphere because Earth's axis was slightly different. Now, this is a huge exaggeration. The tilt is like 1.5 degrees, but it's enough to shift which North Star we have or where we see the North Star. So alignments, like I said, are these other ways that we look for meaning, but the alignments happen due to the function of planetary formation. So how we see the sky is a function of how it was formed. So the planets were all formed from this condensing nebular cloud that expelled all of this material. Then it gravitationally retained that material in a disk through conservation of angular momentum, like a rotating ice skater. And the solar system was born in this disk. So about 4.6 billion years ago, the sun was formed. There was likely a supernova explosion that set off that condensation inside this rotating cloud of gas and dust. That material flattened into a disk. The planets formed around that disk. And because of that, the orbits stay really close in that plane. So when people say that the planets are in alignment, they're nearly always in alignment. That is nothing special because they all formed in the same planetary plane. So the orbits stay pretty close to that plane. Not perfect, but pretty darn close. So because of that, this concept of alignment conjunctions is pretty common. A quick little animation, if it's going to play. Yay, there we go. So here's a little animation that shows that. So we can see these areas of accretion that became the planetary orbits. Think about it as like rolling a snowball together. And the early solar system was a much busier place. We had lots and lots of collisions. We likely have 8 to 10 more planets outside the orbit of Pluto. This is what I did study for my second master's. More dense material settled inside, less dense material settled in the outer solar system. But that planetary formation is what gave us this flat system. That's why we see that. And because of that planetary formation, we end up with this inner and this outer zone where we had the lighter material that settled outside with this lower density. We had the heavier rocky metal silicate elements that settled inside. And that plane, remember I said that everything generally isn't about the same plane. Mercury's orbit is the most tilted. Earth's orbit is pretty darn close. But you can see most of them are really, really close to that. Why is Mercury's tilted? It's probably hit by an asteroid. Why does Venus rotate backwards? It's probably hit by an asteroid. That's the answer to most anomalies that we see in the solar system because it used to be a very busy place. We see this evidence of these impacts and craters in these strange things like orbital tilts and backwards rotations, that there's just no other explanation that something had to have disrupted that. So because of this, if we look to the right, that's what we see. So if we look west at sunset, we generally see, if we think about those orbits and where the path of the ecliptic is, Mercury falls just outside of that. Venus falls just outside of that. So that's why when we look west, we will generally see Mercury and Venus not far from the sun. They have a small orbit. They can't really be. So then if we're looking at sunrise, we see the same, also very close to the horizon, close to the sun. So really, what astronomers mean by alignment is a line of sight effect, which is probably not what people talk about when they're like, oh, the planets are in alignment. Remember, they're always typically in a line. But what most astronomers mean is like the way we actually see it. The planets are not actually in a straight line in space. They simply appear that way because they're in the same region of sky and they orbit in nearly the same plane. And that's how we observe them from Earth. So on that planetary parade in 2025 and last year, this is probably more what it looked like. This is more accurate. So remember, Mercury is the one that is a bit outside of that. Obviously, we can't see Neptune with the naked eye. Saturn on a very, very clear night, definitely not from Northern Virginia. But that's that straight line, not a very straight line. So, we can see like, are they really aligned? It's cool to say. So if we think about that as the myth versus reality, and I feel like since I taught high school, this is a lot of what I was doing is like speaking truth to their teenage brains and trying to get them to see like what the scientific fact was, which is kind of the big challenge with young people these days. Wow, I just totally did that. I dated myself. But the planets are not all in a straight line. This is not actually rare. Conjunction is different than true alignment. Conjunction is what's based on our line of sight. And we actually won't have another one of these a true alignment we won't have until the 2040s. And that's actually going to showcase Mercury, Venus, Mars, Jupiter. But this has no connection to natural disasters. There are no gravitational effects. But it does have some historical and cultural significance. The Mayans and the Babylonians recorded these as early as BC 125, and early European astronomers tracked these. But there has been a very famous true alignment. And if you are a student of astronomy, or if you were born before 1970, you have probably heard of this. I was not, but I definitely know about this. So we actually we used a true planetary alignment to launch the Voyager probes. So when in 1977, we took advantage of the actual alignment, which is when they are physically closer to in their orbits. So we had the planets of Jupiter, Mars, and Saturn that were physically closer in their orbits to each other, and we were able to do a gravitational slingshot around them. And that's how we were able to launch those probes, is really like taking the gravity from that. So when the spacecraft uses the gravity of the planet, changes its trajectory, and the gravity of the planet pulls on the spacecraft as the spacecraft swings around the planet, gains speed, and the speed boost can be used to help the planet or the spacecraft escape the solar system, which is what it did. So here's a little illustration. It essentially steals the gravity. This is the path of Voyager 2 through its encounter with Neptune 12 years later. And I believe both of these have left the solar system. I have stood in JPL in the center of the universe. They actually have a thing that says center of the universe and seen the signal from this. And I thought that there is no more tracking of this, but I'm too sad to look up and verify if that is true. I really don't want to believe that that is true. But the closer it gets, the greater that deflection. And it's possible to have a very small deflection, very few degrees, which is actually what we would do in the case of avoiding a impact from, say, an asteroid. If you've seen, oh my gosh, Bruce Willis, what's the movie? They blow up the asteroid. Not Contact. Oh, it's going to kill me. Armageddon. That would be a terrible idea because then you have one impactor that becomes thousands of impactors and you give it more kinetic energy. What we'd want to do is just provide a little bit of a push to move it out of its orbit. So we would actually use the same sort of thing, probably a small spacecraft, to be able to move an incoming near-Earth object. Oh, this is my favorite picture taken by Voyager, and I just love these. And in the Griffith Observatory, they have really, really big ones. And on a really high resolution, you can actually see a bunch of moons around Saturn. But I just love that, like, this was an actual true alignment and just the really neat science that they were able to use to be able to take these images. And it wasn't until, what, 50 years later that we were able to get other images of these planets with the Juno mission. Okay. Hold on. Go. All right. Quiz time. Which object had the greatest gravitational influence over you at birth? I had to actually work out the math for this for a problem. So I then gifted it to my students to work out as well. It's actually not hard math. It just takes a lot of pages. Oh, sorry. There, now you can put in your answers.
I already posted mine in the chat a long time ago before the question
Sorry.
even came up. I thought I was, here's an interesting fact.
I wasn't even looking at the chat. Sorry about that. Anyone know the answer? You just call it out.
I don't want to call it out. I know the answer.
You can call it out.
Your mom's OBGYN.
Yep, that is the answer. Greatest gravitational influence on you was your mom's doctor or midwife or whoever it was, because gravity depends on mass and distance. So even though Mars is massive, it is tens of millions of kilometers away. I had a funny professor that made us work out that math. Yeah, so we know that the gravitational force on a newborn, if you're interested in the math, I actually have the math, but that's why distance dominates that effect. So even the massive planet Jupiter has a tidal effect of about 170,000 times weaker than the moon. And Mars, which astrology really emphasizes, is about 360,000 times weaker. That took me a really long time to put that chart together. So Mars's gravitational energy or pull on Earth is roughly at the moment of birth. Oh, sorry. No. So yeah, Mars's gravitational pull on Earth is roughly 50 times. Is 50 times. What was my math there? 78,000. No. It's 7 decimal points. 0.000000001 times on you. So it's very, very weak because we just use the gravitational constant equation. So the obstetrician is exerting 50 times more gravitational force than Mars does. That's the math. Fun problem to give your students. But do planetary alignments affect Earth? If the planets influence us physically, the only mechanism available is gravity. And the gravitational pull from planets on a human body is pretty darn negligible. And this decreases extremely with increasing distance. The moon is really what dominates the tidal forces, and we see this with tides. So we know that Mars is 2,500 times weaker than the moon's, but it actually does pull on the water. It pulls on the rock slightly. And the third part of my talk here is going from messages to mechanisms. For thousands of years, people have interpreted the sky as messages. Astronomy really replaced those interpretations with mechanisms. So first we went from meaning, then we were looking at the messages, and then just really translating that into mechanisms. Physical processes we know explain what we actually see. So the mechanisms that mostly explain this motion are rotation, revolution, and gravity. Astrology really treats the sky as a system of messages, but astronomers treat it as a system of mechanisms. So as we refined our tools, our models have really evolved. So Tycho Brahe, who was one of my favorite astronomers, he had this very different view of the solar system, and he had these very concentric perfect circles. And we know that the models have really changed. Aristotle and the Greeks had placed Earth at the center of the universe, and they had the planets moving on perfect circular spheres. Circles were represented perfection and order. Claudius Ptolemy created this.
The Ptolemaic model, published around the year 150 AD, fixed the Earth at the center of the universe.
This fun system of epicycles to explain why it looked like Mars went backwards, because from a perspective around Earth, there are periods in its orbit, like right here, where it looks like it's going to go backwards. So he explained that by creating these epicycles. So this was what was used for centuries, but it became increasingly complex. Imagine adding other planets to that, then the moon to that. Some of them had more epicycles than others. And after Copernicus, on his deathbed, revealed his proposal of placing the sun at the center, this then made much more sense. Kepler then further refined that by describing models of orbits as ellipses, not perfectly circular orbits, which explained why the planets appeared to speed up and slow down. And we can see that if we think about a perfect circle as being a eccentricity of 0 and a straight line being an eccentricity of 1, Earth is actually nearly perfectly circular. Mercury is pretty elliptical, and comets have an eccentricity of about 9. So they are going to swing very close to the sun and back out again. But they're all not perfect. So Kepler had these 3 laws of planetary motion. The planets orbit the sun with the sun at one focus. And he discovered that the planets move in these ellipses, but he really didn't discover the why. It was Newton later on that came up with the why, and we now know that that is gravity. So the same force that holds an apple also holds the moon in orbit. And the physical law that explains, and this also became the physical law that explained both the motion of the Earth and the heavens. So if you keep firing a cannonball fast enough, it's going to eventually fall towards Earth, but it keeps missing the ground. That's an orbit. If we fire it fast enough, it'll just end up leaving Earth's gravity but get sucked into an orbit around it. Obviously, you'd have to fire it really, really fast. But a planet works the same way. Gravity pulls on it towards the sun, while sideways motion carries it forward. And the result is this curved path towards the sun. So an orbit is really just this balance between gravity pulling inward and motion carrying the planet forward. So Newton's laws then described gravity really well, allowing astronomers to predict motion with really fantastic accuracy. But then we had Einstein that showed gravity wasn't actually a force pulling across space. Instead, there are massive objects like the sun that warped space-time around them. And the planets moved along natural curves in that warped space, what he called space-time. And that's a perfect example of astronomy really moving from interpreting patterns to understanding mechanisms behind them. And my favorite quote that I used to always tell students was, space-time tells matter how to move, matter tells space-time how to curve. And we can see the objects with greater mass create a bigger hole, and a black hole would be how he represented it, as like an infinite hole. All right. I think this might be my last question for you. When is the northern hemisphere closer to the sun? And for time's sake, because we are already like nearly out of time, I guess we'll just move forward. The northern hemisphere is actually closer in winter. So I used to always show this to my students. Bill, what is time? How much longer do I have?
if you could shut down at 8 o'clock, then we could have Q&A.
Yes, yeah, I can do that. Okay. Um, the last, I want to show you like I have 5 minutes. I'll show you two things. I was going to do a whole section on eclipses, but I'll show you one thing here. Eclipses have been predicted for a long time. The one that I really like to talk about is how Christopher Columbus he had an astronomer who knew there was going to be an eclipse. He really needed food. So he used this to really manipulate the Aztecs into giving him what he wanted. He said, if you don't do this, I am going to have God block out the sun. It would have probably had a very different course of history if that had not happened. So he got a lot of gold from them, and a lot of different resources. And it's easy to see why people would attach so much meaning to eclipses. I wished I was going to the one in
Hmm.
Spain coming up. I'm going to skip these. There's one other thing I wanted to show you, and that has to do with space rocks. Um, So I love meteors and meteorites. This is what I studied was planetary science. So just quick vocab: asteroid is when it is orbiting the sun. Meteoroid is that fragment traveling through space. Meteor is the streak of light, like this. And meteorite is once it survived the atmosphere and landed on Earth. But there are some pretty famous ones because this was our only source of iron for a very long time. And the most famous is King Tut's dagger. There is no way they had no process of smelting iron. So the earliest swords, and I actually just saw one when I was in Prague, and they didn't identify it, but it was a iron sword from like 800 AD, and it had to have been meteoritic iron, and it was from the same region. And so they have now actually traced this to a specific meteor, and this was buried with King Tut. So when we look at things like cosmic coincidences, we can think about them as as something that leads us to greater understanding. Astronomy is really good at explaining how patterns occur. We understand now orbital mechanics, planetary formation, why the sun and the moon appear the same size in our sky. But explaining the mechanism doesn't necessarily eliminate that meaning. For a lot of people, understanding physics actually deepens the sense of wonder about the universe and our place in it. Um, there's also been pattern seeking gone wrong. The canals of Mars were a 19th century observational illusion by an Italian astronomer, Giovanni Schiaparelli. He reported seeing canali, which he thought were channels by Martians in 1877. This was mistranslated, and Percival Lowell then really popularized this theory that there was irrigation for a dying civilization. And this wasn't disproven until the Mariner mission. So it's not always right. One of my favorites is looking at patterns such as the face on Mars. This is a 1.5 mile long mesa on a region of Mars. This is taken by the Viking orbiter. And for years, people looked at this and said, oh, it must be a face. But later, high resolution revealed that this was really just an eroded feature, and it was a shadow effect. Something else I like to show people is this picture. If you see someone who is young or old, I love that one. So our position as meaning seeking derives from the fact that we are the only species that can plan for our distant future. So that's really an asset to us being human. It's not just for our present needs. We can actually plan out. So when animals and humans plan for our daily needs, our goals are proximate and the value is more or less obvious. But when we have to plan over longer horizons, that goal is really distant. It may not even exist, or it may be of an unknown kind, and its value is much more uncertain. So in those situations, we need more overarching values. We need moral, religious, ideological to give meaning to planning. So, in other words, to wrap up here, the need for meaning comes from our unique human capacity for foresight. That meaning of life becomes our goal. Our existential questions are really outgrowths of the more general drives that to find these causes in everyday events and to find patterns in the world. Humans have always looked to the sky for meaning, and astronomy gives us something just as powerful, understanding. The sky didn't lose its wonder when we learned how it works. If anything, it gained it. Thank you very much. That is how you can reach me. That is my LinkedIn. I have a slew of references. If you actually want them, I have a ton more too. Thank you.
I'll try to get everybody up. Let's see. Let's get them to. Oh, here we go.
And I think there have been questions, and I have not seen them
right.
because my screen blocked it. So I am so sorry.
Well, I think Alan has a few questions.
Yeah, I don't like to interrupt the presentation with questions, so that's fine. But I marked them so I could find them later. And they're just about the presentation. First of all, I wanted to say thank you for your service. The world is like a way better place because you're in it doing what you're doing.
Hey,
And this was a fascinating, absolutely. And you answered a bunch of questions in the world I didn't even know I had.
cool.
About your presentation itself, can I use that horoscope URL?
Absolutely.
I actually got a test like that when I was at Clark University like 20 years ago in my psychology class. And so I knew it was going to be the same one. So I cheated and just picked the one in the middle.
Nice.
So if I could get that. And the second one, what was that optical illusion in one of your slides? It was before the what direction test. There was a slide with the four-pointed star inside of colored squares. Do you know which one I'm talking about? It's a four-pointed yellow star, and there were two charts.
Oh.
It was at the bottom of one of your slides.
Oh, bottom of slide. No, not that one.
And I missed that one.
It was about parallax.
Was it? And in one of them, the four-pointed gold star is inside the red square, and it was inside a different colored square in another one.
Was it this?
Yes.
Okay.
Exactly.
Yeah, so this one is just showing that if you're at two different viewpoints looking at the same object,
got it.
so
Thanks.
boxes just represent like a different background stars. That's actually not a great picture. I had a better one that I used to show that I think I'm going to flag that and replace that.
Anyway, every other question I had when they came up, you answered them, and I even had to burst out laughing when you threw the OBGYN one in, because that's another one I had read a while ago, and I thought, oh, I'm going to be clever and put that in the comments.
Nice.
Thanks. Great presentation.
Thank you. Other questions?
I'm looking now.
The brightening of the sun during the planetary formation video, that would have just been the onset of fusion.
Oh yeah, that's right. That's okay. That's what that represented. Okay, got it. Because I noticed that the accretion disk changed very dramatically after that, and that's something I had not ever thought of before. So thanks.
It is actually very difficult to find those sorts of simulations and visualizations that are accurate. I edited a textbook a while back, and I tried to find just an accurate picture of the solar system. Didn't exist, and I decided they weren't paying me enough to create it.
Yeah, it's tricky because the inner solar system is so much cozier than the outer solar system.
Yeah, exactly.
I think.
Yeah, and
going
Bill,
through
you
the
put in the
chats.
moon orbital inclination. I don't know how I got so behind in that talk. I should be able to. I've done that before in under an hour. If I'd have gotten to the section on eclipses, I would have hit your point about the moon's ecliptic in 5 degrees, and that's why we don't have eclipses all the time.
Mm-hmm. So you're looking forward to getting back with teachers and students.
I am. Yeah, I have actually been away from students. I was teaching astronomy at least remotely after the pandemic when I moved to the East Coast, but now California no longer does the universities don't accept remote or lab classes that are not in person. So I had this amazing observational astronomy class that I created, but now it has to be offered in person. So I was teaching remote astronomy, and I made the whole class about robotic telescopes. It was awesome. And I was teaching that until 2023. But I've just been designing programs and writing grants for the last 2 years. And so I've been deeply immersed in the grant writing process. Um, but yeah, being stuck on a computer all day kind of stinks. And I'm
Telling
not
them
doing
what
like anything
telling them
related
what they want to
to
hear.
what's that?
Telling them what they want to hear.
Yeah. I live in the land of data centers, so at the community college, that is what we are focused on. And let me tell you how passionate I am about that.
Yeah, yeah. Problematic.
Keeps from me.
So, what do you think you'll do with this Maryland position? Um, will you be in
Um,
person?
it's yeah, so I'd be going to districts and helping districts sequence their science and fitting it into their day because now a lot of states, and Maryland is one of them, have minutes that they require for literacy and for math. And my role will be helping them see like this is where science can fit in and this is how you can do it. So there are 27 districts in Maryland, so I'll have to visit every one in a year and I'll be working with all their teachers. It's really like working across a lot of systems.
Mm.
And that's more the way I think is like attacking a problem from multiple levels and then getting like the superintendents in a room and getting them to, talk about patterns and trends and have them come up with their own solutions. Cause that's like I can see something, but if I'm not the one that's actually solving the problem, like I'd rather have,
Hmm.
position people to come up with those things. So I'm excited to do that. But by the time in the next couple years, I am hoping that I will be a consultant with the capacity to do all of this on my own time and make money doing it.
Yes.
That's the end goal.
Yep.
Can I ask another question?
Sure,
Absolutely.
Alan.
As long as I can
What
keep looking at your screensaver, it's great.
in your teaching experience, what is the general ratio in your classes between male and female students, and do you see that shifting over the past decade?
That is a great question. So, given I have not taught in person since 2020, but I do have a student in college, my son, and I've seen the data in that there is now, for the first time, a shift of more girls than boys.
Hmm.
Mhm.
I would say that in my engineering classes that I taught, oh my gosh, 95% boys. 100%, yeah, there's like no girls. But in astronomy, I think there started to be more of a shift. Initially, it was definitely more males, but I was really intentional about the way that I would reach a lot of the girls. And I had a girls in STEM um, program, and I had this group. I had a club that ended up being all girls, and I guess that was like a huge focus for me was the girls. So I would say by probably year three, it was pretty even, if anything, more girls.
Mhm.
But I don't know that that's like I think it started a lot of momentum. Um, yeah. So yeah, I definitely saw a shift. And in my earth science classes that were more like the dumping ground classes, um, that was a lot of boys. A lot of times they would be more behavioral problems. Um, they would be just kind of pushed in, and it would be the boys that were louder that other people didn't want to deal with. And it didn't necessarily speak to their ability.
Hmm.
Um, it was more of a management thing. So yeah, I kind of saw the whole gamut. I'm really curious what those numbers are now. Um, I was just offered a position teaching engineering, and I know that their ratio is much higher for boys than girls.
Hmm.
But I know I've read a lot of the studies about how, now boys are like super apathetic, and it's the girls that are the ones that are doing more and taking more. And, like I know that in the southern schools, there are some schools that are like 75% girls now, like they're freshman classes. So you're now really seeing this shift for the first time. So it'll be interesting to see in the next couple of years.
Yes.
That's great news. Thanks.
All right, I guess we'll wrap it up unless somebody has a burning question. Um, this was great, Christine. I'm so happy that we were able to make this happen. And
Me too.
boy, oh boy, I wish you wonderful prospects in the weeks and months ahead.
Thank you so much. And feel free to reach out to me, anyone. And I'm thankful for the opportunity. Thank you for asking me to join.
Thanks very much.
Thank you.
Thank you. This was really fun. I appreciate
Great.
it.
Okay,
Thank you.
so long.
So long.
Bye, bye,
Thank
everybody.
you, Bill.